The Molecules and Light simulation is an innovative educational tool designed to help students understand how light interacts with molecules in our atmosphere. This interactive simulation allows students to investigate the behavior of different types of light, including infrared, IR, microwave, and visible light, as they interact with various atmospheric molecules. By providing a visual and hands on approach, the simulation enhances students' understanding of the fundamental principles of light matter interactions. The Molecules and Light simulation focuses on the interaction between light and molecules, a crucial concept in atmospheric science and spectroscopy. It illustrates how different types of light can be absorbed, scattered, or transmitted by atmospheric molecules, affecting the Earth's climate and the quality of the air we breathe. The simulation includes various tools and visual aids to help students explore these interactions in depth. The simulation allows students to investigate the interaction of four types of light with atmospheric molecules. The infrared light is absorbed by molecules that have vibrational and rotational energy levels, such as carbon dioxide and water vapor. The microwave light is absorbed by molecules with rotational energy levels, such as water vapor and oxygen. The visible light is primarily scattered by molecules and particles in the atmosphere, contributing to phenomena like the blue sky and red sunsets. Students can explore how different types of light interact with various atmospheric molecules, including carbon dioxide. CO2 absorbs IR light, contributing to the greenhouse effect. Water vapor. H2O absorbs both IR and microwave light, affecting the Earth's energy balance and weather patterns. Oxygen. O2 absorbs microwave light and plays a crucial role in the Earth's atmosphere. Nitrogen. N2 is relatively transparent to IR, microwave, and visible light, but can scatter visible light. The simulation illustrates the different mechanisms by which light interacts with molecules. Molecules, for example, absorb light when the energy of the light matches the energy difference between the molecules' energy levels. Molecules and particles in the atmosphere can scatter light in different directions, affecting the appearance of the sky. Light that is not absorbed or scattered by molecules is transmitted through the atmosphere. The simulation includes visual aids, such as graphs and animations, that show the absorption spectra of different molecules and the scattering of light in the atmosphere. These visual aids help students understand the complex interactions between light and molecules. The Molecules and Light simulation provides a hands-on approach to exploring how light interacts with atmospheric molecules. By investigating the behavior of IR, microwave, and visible light, students can understand the following key concepts. The infrared light is absorbed by molecules with vibrational and rotational energy levels, such as CO2 and H2O. This absorption contributes to the greenhouse effect, where the Earth's atmosphere traps heat and warms the planet. The microwave light is absorbed by molecules with rotational energy levels, such as H2O and O2. This absorption affects the Earth's energy balance and weather patterns. Visible light is primarily scattered by molecules and particles in the atmosphere. This scattering contributes to phenomena like the blue sky and red sunsets. The blue sky is a result of Rayleigh scattering, where shorter wavelengths of light, blue and violet, are scattered more than longer wavelengths, red and orange. Light that is not absorbed or scattered by molecules is transmitted through the atmosphere. This transmission allows us to see the sun and other celestial objects. The Molecules and Light simulation offers several educational benefits. The simulation provides an interactive and engaging way to learn about light matter interactions. Students can actively participate in the learning process by investigating the behavior of different types of light and observing their interactions with atmospheric molecules. Light matter interactions can be challenging concepts to understand. The simulation provides a visual and tangible representation of these abstract concepts, making them more accessible and understandable. Experimentation and exploration. Students can experiment with different types of light and atmospheric molecules and observe the resulting interactions. This exploratory approach encourages critical thinking and problem-solving skills. The simulation provides a practical application of the principles of light matter interactions, which are fundamental to many real-world phenomena, such as the greenhouse effect, weather patterns, and the appearance of the sky. This helps students see the relevance of these concepts in everyday life. The simulation introduces students to the process of data collection and analysis. By observing the absorption spectra and scattering of light, students can collect data and analyze the relationship between the type of light, the molecule, and the interaction mechanism. To implement the molecules and light simulation in the classroom, teachers can follow these steps. Begin with a brief introduction to the concept of light matter interactions and their importance in atmospheric science and spectroscopy. Provide examples to illustrate these concepts and explain how the simulation will help students understand them. Demonstrate the simulation to the class, showing how to investigate the behavior of different types of light and observe their interactions with atmospheric molecules. Explain the importance of observing the absorption spectra, scattering, and transmission of light and how they relate to the principles of light matter interactions. Allow students to explore the simulation in small groups or individually. Encourage them to experiment with different types of light and atmospheric molecules and record their observations. Provide worksheets or prompts to guide their exploration and data collection. After collecting data, have students analyze the relationship between the type of light, the molecule, and the interaction mechanism. They can use the absorption spectra and scattering patterns to interpret the data and draw conclusions. Facilitate a class discussion to share and compare findings. Encourage students to reflect on what they have learned about light matter interactions and their implications. Ask them to consider how these concepts apply to other areas of science and everyday life. The molecules and light simulation is a valuable educational tool that brings the principles of light matter interactions to life through an interactive and engaging context. By allowing students to explore how IR, microwave, and visible light interact with atmospheric molecules, the simulation provides a hands-on learning experience that enhances understanding of these fundamental concepts. This interactive approach not only makes learning more enjoyable, but also fosters critical thinking, problem-solving skills, and a deeper appreciation for the relevance of light matter interactions in the real world.